Hi friends, in this session we will study about the coordinate geometry in 3 dimension. Let us explain you about the 3 dimension first. You see here in this figure, this is our axis, x days. This green line represents x axis, and this orange line represents y axis. Y days. This is our blue, this is our z axis, z days, and this is our origin where all the axes meets at origin perpendicular to each other. So they all the axes are perpendicular to each other. Just you look at this. First I change the ink. This is perpendicular, z axis perpendicular to y axis, z axis is perpendicular to x axis, and x axis is perpendicular to y axis. So these all are perpendicular to each other. We already have seen that in 2 dimension there are 4 quadrants. The 2 axes, x axis and y axis are there. That divides these in 4 quadrants. Okay, quadrant first, quadrant 2, quadrant 3, quadrant 3, as I saw you in this diagram. Now you get this. If we have this, this is our axis, this is our another axis. This is in 2 dimension. We see we have this is our x axis, x days is origin, y days. In 2 dimension we see that it is the first quadrant, this one is second quadrant, this one is third quadrant, and this one is fourth quadrant. So we have 4 quadrants are there. Here we see the in first quadrant the x is positive and y is positive, both the coordinates are positive. Here x is negative and y is positive. Here you see x, y both are negative. Here you see x is positive and y is negative. So we have given the name to the quadrants because it divides these 2 axes, divides the plane in 4 parts. This one is first part, second part, third part, and fourth part. But here in 3 dimension we see there are 8 octants we get here. You see here in this space we get the space, the whole space, it divides all the 3 axes in 8 parts. So the first part you see here, it is x, y and z. So this sort of upper part is called the first octant, and then second, third, fourth. We cannot give the name in a serial order. So if we have to find out the octant, I explain you here. You see, just a moment, I just remove this from here. Now I would like to explain you that if we have x, y, z, o x y z space, o x y and z space, it means this octant. There are 4 octants are in upper side and the 4 in lower side. 1 2 3 4. Here in downwards you will see down of the y or x axis you will see 1 2 3 and 4. So we have 8 octants are there. So o x y z, we will get the coordinates, x coordinate will be positive, y positive and z positive. If we have o x days y z, so x days, wherever the days is there, and x days, y days or z days, whatever is there, it would be negative, other would be positive. So it is negative, x days is negative, y is positive, z is positive. If you have o x y days z, so it is x positive, y negative and z positive. Or if you have o y days z days, x positive, y negative and z negative. So in this way you could plot the point in a space. If you know the octane, which octane is this, so you could put the symbol to the points of the coordinates. So this is the way we could plot the point we get of any point coordinates x, y, z. All the three coordinates we will get over there. So first of all, we have studied in 2 dimension about the distance formula. There was a distance formula that the square root of x2 minus x1 whole square plus y2 minus y1 whole square. If there are 2 points in space, then the distance would be the distance formula like this. Distance formula 3D. So it would be like this. We have 2 points. Point P has the coordinates. Just I change the color of ink. Point P coordinate x1, y1 and z1, and point Q whose coordinates are x2, y2, z2. Now we have to find out the distance between P and Q in space. So we will get in this way. PQ, we already know the formula of distance formula in 2D. I derived it in our one of the episode, one of the video. So here I just add this x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So we get here this distance formula x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Now we see the section formula here. It is the previous, we just adding z coordinates there, so we will get other formula. Section formula, if in section formula the point are same P and Q, if we have a line in space like this, we have a line in space, this is our P point, this is our Q point, and this is our R point, which divides this PQ in m:n ratio, m:n ratio, and the coordinates of point P are x1, y1, z1, and Q x2, y2, z2, and R we have to find out the coordinates of point R. We assume x, y, and z. So we know already the section formula in 2 dimension. We have explained it earlier in my previous videos. So I just put here. We don't take much time for this because we have to study more thing about the 3 dimension in this episode. So I would like to tell you x, we know that x is equal to, in section formula, if it is internal divide PQ in m:n ratio, then m x2 plus n x1 over m plus n. For y, similarly we get m y2 plus n y1 over m plus n. There is one more coordinate is there, that is z. So we have to find out also for z. So mz2 plus nz1 over m plus n. So this is the internal uh, uh, division, internal form of the section formula, internal. So I put here the name internal, internally divides. Now externally divides, we see if it externally divides, we get x is equal to mx2 minus nx1 over m minus n. This is the, I would like to explain here in this figure. First we see how we get this. So this, just a moment, we have a line, we have the points P and Q here. This one is P, this one is Q, and sorry, we take here Q, and this one we get here, just a moment, we take a point R here. So the coordinates of this point P are as x1, y1, z1, okay, and Q is x2, y2, z2, and R we know that it is x, y, z. We assume we have to find out x, y, z. Now it divides this PQ externally, m is to n ratio. So we will get this formula, x is equal to mx2 minus x1 over m minus n, and here for y we also get the same thing. For y we get m y2 minus n y1 over m minus n. Similarly for z, m z2 minus n z1 over m minus n. So this is the section formula, externally divides the point a given line segment. Now we see the midpoint formula. For this we see the midpoint formula here in 3D. Now you look at this, if we have a line segment like this, and there are 2 points and B, and there is a point C in between this. I just changed the color. This is a point C. We divide AB in the same ratio, or 1:1. It is the midpoint of AB. AC is equal to AB. Here AC is equal to CB. So this ratio is 1:1 now. So if 1:1, if we put in internal division formula, section formula, we get like this, because the division formula is x is equal to m x2 plus n x1 over m plus n. So here m and n both are 1, m is equal to 1 and n is equal to 1. So we put here x is equal to m1 z x2 plus x1, 1 plus 1. I arrange this, x1 plus x2 over 2. So this would be the midpoint formula. Similarly for y we get y1 plus y2 over 2. Similarly for z we will get z is equal to z1 plus z2 over 2. So in this way we could easily find out the midpoint formula. Now I would like to explain about the centroid of triangle. If you have a triangle like this, we have to find out the centroid. We are not getting proper triangle here, so I just delete it and make another one for you. There is a right angle triangle only there. So I make a triangle here. This is a triangle ABC. We have a triangle ABC is here, A, B, C. So look at this. If you see here, we centroid, we have to find out the centroid coordinates of the centroids. In a space. So we have the coordinates of point A is given x1, y1, z1, and the coordinates of point B x2, y2, z2, and point C x3, y3, z3. Now we put a median from point A on BC. So this is the midpoint of that. So we will make this median, and one more median from B on AC. So we get in this way. The intersecting point of these two median is called the centroid of the triangle. So we see here, this the centroid is we denoted by G. I changed the color of ink, sorry. So it is G, which is the centroid of this, and this is point D, and this is point E. So we could easily find out the coordinates of point D. So I would like to explain you about the coordinate of point D. Coordinates of point D. By midpoint formula we could easily find it out. So we know that the coordinate of point D are x dash, y dash, z dash. So x dash is equal to x2 plus x3 over 2. Similarly, y dash y2 plus y3 over 2. Similarly, z dash z2 plus z3 over 2. So this would be the x dash, y dash, z dash. We have got this, and the centroid divides the median in 2:1 ratio, 2 towards the vertex and 1 towards the side. So this ratio would be 2:1. This would be 2, and this would be 1. So m we have 2, m is 2, and n is 1. And here x1, y1, z1, and x dash, y dash, z dash. So we through the section formula we find x, y, z, the coordinates of point G. X, y, z only. So we find it through this. We get x is equal to m is 2, and x dash plus 1 x1 upon 2 plus 1. So we get here 2 x dash. We know that x2 plus x3 over 2 plus x1 into 1 x1 over 3. So we could find here 2 will eliminate to each other. Here we get, now you see, x2 plus x3 plus x1 over 3, or we can arrange this in this way: x1 plus x2 plus x3 over 3. So this would be the x x coordinate of centroid. And similarly we could get y. So y is equal to y1 plus y2 plus y3 over 3, and z is equal to z1 plus z2 plus z3 over 3. So in this way we could find out the coordinates of the centroid of a triangle. Now we see the coordinates of a centroid of a tetrahedron. So first I would like to explain what is tetrahedron basically. First I draw a tetrahedron here. Look at this. This is like a pyramid, if you see. So it is a triangle. Okay, just a moment. Just a moment. I change this color of this side also, so you can easily recognize the base. This one is green now. Okay, so this is a tetrahedron. It is a pyramid, triangular pyramid we have. So there are points, vertices. There are 4 vertices are there. One is A, other one is B, then C and D. There are 4 vertices are there, and the coordinates of vertices already we know that it is x1. We put x1, y1, z1 here, and it is x2, y2, z2. It is x3, y3, z3, and it is x4, y4 and z4. So these are the coordinates of the vertices of a tetrahedron, and we have to find out the center of the tetrahedron. I would explain what is the center of the tetrahedron. So first we look at this through this blue green pen. Okay, so first I draw the centroid of this face ABC, this triangle. So I draw a line. This is the median. This is the E point of this we have drawn here, and one more median I will draw from point B on AC. Edge AC, I draw here another median. So these two median meets at this point. So this is the centroid of this triangle ABC, and I draw another centroid for this triangle ADC. So I take some other color and draw one median from here to here, and one median from D point to this. So these two medians, one is this and one is, and the two centroids are there of this triangle is, and there is one triangle of this. So what we have to find out the centroid of tetrahedron, it means we have to draw one line from vertex D to this centroid on face ABC. So this is I put here the name for this. This one is G1 and this one is G2. Sorry, just a moment. I change the color here there. Just a moment. I put some different color for this. So we are making from here. Okay, this is another centroid we have got on this face. So you see here, first of all we put some name for this. This centroid is G1 and this one is G2. We have to find out the centroid of the tetrahedron. Then one more line we have to draw from vertex D on this up to this centroid. So we will make a line here, this line G1D, and one more line from vertex, because this is the G2 centroid of this triangle ADC. So we have to draw from point B. So we take one another line of different color, one thick line I draw here. So this would be like this. See, both the line I change the color first because the color is not getting sufficient. One more color if I draw. What color should I take here? This color I take. I take the small line, thin line here. So I made these two G. Okay. So this is one line, and I draw another line from this to this place. So we are in a space. These two line from vertex to the centroid meets is called the centroid of tetrahedron. So that we have to find out. So if we derive this formula, first we find out the centroid of the G1 and then centroid of the G2. So centroid of G1, the coordinates of point G1, first I explain you. Point G1, we assume that G dash, Y dash, Z dash. So it is, we know already that it is equal to X dash is X, it is X1, X2, X3. In this triangle it is G1. So X1 plus X2 plus X3 over 3. Similarly Y dash, Y1 plus Y2 plus Y3 over 3, and Z dash, it is Z1 plus Z2 plus Z3 over 3. So this is the way, in this way we could easily find the centroid of G1, coordinates of the centroid G1. Now similarly we have to find the coordinates of the point G2. G2, which are X double dash, Y double dash, and Z double dash. So it is X double dash. Here you see X1, X3, X4. So X1 plus X3 plus X4 over 3. Similarly for Y and Z we will get the same thing. Just a moment. Y double dash is equal to Y1, Y3, Y4 over 3, and Z double dash is equal to Z1, Z3, Z4 over 3. So in this way we have found out the coordinates of G1 and G2, and this G1 G2 meet at in the space with a ratio. What we could say that the ratio for this we know that this point we take 1 and this point, okay, B G2. So it will divides is 3:1 ratio. Now 3:1 ratio if we see B and D and B and G2, or there is a that one the centroid of this is G. So the G divides 3:1 now. 3 to the vertex and 1 there, so 3:1 we will put here. Just I change the color first and then I explain you. G divides the BG1 G2 in 3:1 ratio. So M is equal to 3 and N is equal to 1. So now we will find out the coordinates of G, because the coordinates of B we already know that coordinates of B we know that X2, Y2, Z2, and G2 coordinates we have here for G2 this coordinates X double dash, y double dash and z double dash we have here. So now we could easily find out x, y, z are the coordinates of this G. X, y, z are the coordinates of this G. So we have to find out the coordinates of G. So we see that x is equal to 3 and G2 is x dash plus 1 and into x2, 3 plus 1. So x is equal to 3 over x1 plus x2, sorry, x3 plus x4 over 3 plus x2 over 3 plus 1, 4. So let us see what happens. So see here, both 3 will eliminate to each other, and then we get here, I arrange in this proper way, x1 plus x3 plus x4 plus x2 over 4. If we arrange in a proper way, we will get x1 plus x2 plus x3 plus x4 over 4. Similarly, we could easily find out y is equal to y1 plus y2 plus y3 plus y4 over 4, and z is equal to z1 plus z2 plus z3 plus z4 over 4. So we have seen in this session lots of things. We have studied about the 3-dimension geometry, the preliminary study about the 3-dimension geometry. First of all, we have seen what are the octants. There are 8 octants are there in 3-dimension space. The coordinate, the point what we put here, how we give the symbols to the positive or negative to the plotting of a point. So wherever the x, y, z in the symbol, so we have to put always plus, and if there is x dash, y dash, z dash, wherever the dash is there, x dash or either y dash or z dash, so we have to put their negative. So this is the plotting of the points. We have seen the 3-dimension geometry, the distance formula. If you have the coordinates like p, x1, y1, z1, x2, y2, z2, x3, y x2, y2, z2, we have to find the distance between 2 points in a space. We could find through this formula x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square, and the square root of these all. Now we have seen about the section formula also. So in section formula, we have seen that internally divides the point, internally divides the line segment PQ whose coordinates are x1, y1, z1 and the x2, y2, z2, and the coordinates of the point which divides these two in m is to n ratio is x, y, z. Then we could find out through this x is equal to mx2 plus nx1 upon over x1 m plus n, sorry, and y is equal to my2 plus ny1 over m plus n, z is equal to mz2 plus nz1 over m plus n. And if it divides the external in this way, p and q are the 2 points x1, y1, z1, x2, y2, z2 having the coordinates, and the point r which divides externally to this pq segment x, the coordinates of the point x, point r is x, y, z, and it divides m is to n ratio externally. Then the formula would be x is equal to mx2 minus nx1 m minus n, y is equal to my2 minus ny1 m minus n, z is equal to mz2 minus nz1 m minus n. So the similarly was just we have to change the sign in externally. We have to put the negative sign instead of the positive sign. Now the midpoint formula you see here, midpoint formula, if the point C divides the line segment AB in the same ratio as is equal to C, where the m is 1 and n is 1, so we put here in this formula, in section formula, internal division section formula, mx2 plus nx1 m plus n. So m is 1, n is 1, x2 plus x1 or 1 plus 1 which is 2, x1 plus x2 over 2, this is the x, and y similarly y1 plus y2 over 2, and z similarly z1 plus z2 over 2. So now we see the coordinates of the centroid of a triangle in its space. So here the coordinates of a point D, by the midpoint formula, it is the median, AD is the median. So the midpoint coordinates of the midpoint we assume that x dash, y dash, z dash, so we could easily find out through the midpoint formula, because the B and C, B have the coordinates x2, y2, z2, and C has coordinates x3, y3, z3. By midpoint formula, x dash is x2 plus x3 over 2, and y dash y2 plus y3 over 2, and z dash z2 plus z3 over 2, and the ratio which divides by the median, G divides the median in 2:1 ratio, 2 towards the vertex and 1 towards the side. So m is 2, n is 1, and we put in section formula again this 2x is equal to 2x dash plus x1 2 plus 1, and we simplify this, we put the value here x dash, x2 plus x3 over 2, and 2 eliminates each other, and we get x1 plus x2 plus x3 over 3x. This is the coordinates of the centroid of a triangle in space. So now we see, and similarly we get the y and z. Now we find out the centroid of a tetrahedron, coordinates of the centroid of a tetrahedron. So tetrahedron is a pyramid, triangular pyramid. Here you see centroid. Where would be the centroid of these? I have explained you. First we take the face ABC. In this triangle we draw the two medians which intersect each other at point G1, and we find out the coordinates of the point G1. The coordinates point G1 is x1, y1, z1. We have find it out. And one another face we take ADC, where there is one median we draw from vertex C to AD, and one another D to AC, which meets at point G2. This is the center of this ADC, and the coordinates of this point G2 G2 is x double dash, y double dash, z double dash. So by x double dash is equal to x1 plus x3 plus x4 over 3, and similarly we get y double dash and z double dash, and G divides the B G2 in 3:1 ratio. G is the centroid, where both the these vertex, if we take from vertex B to G2 meet, and vertex D to this G1, we both meets each other at G in space. So the coordinates of this point x, y, z, where the mummies are kept in pyramid, this at the centroid of the pyramid it is always kept. So B x2, y2, z2, and G2 x double dash, y double dash, z double dash we put in this section formula, because this centroid in space always divides these lines in 2:1 ratio. It's 3:1 ratio now. So we have to put here 3, m is 3 and n is 1. So 3 x double dash plus 1 into x2, and we simplify these, we get finally x is equal to x1 plus x2 plus x3 plus x4 over 4. Similarly y we could get, and z we could get here. Okay, so in this session we have studied lots of things about the primary things about the 3 dimension. In the next session we will see about the direction cosines, direction ratios, and so many other things about the 3 dimension geometry.